This video was produced by the UCD Math Support Centre in conjunction with the UCD Access Centre. What is probability? Probability is a measure of how likely an event is to occur. We measure probability on a scale of 1 to 0, where 0 means the event will not occur, and 1 is where an event will definitely occur. If an event has a 50-50 chance of occurring, we give it a probability value of 0.5, in the middle of 1 and 0. Let's have a look at the probability of some events. What is the probability that it will rain in Ireland this week? It will most likely rain in Ireland this week, so we assign this a probability that is close to 1. What is the probability of winning the Lotto? Everyone knows that the chances of winning the lottery is very, very, very small. So we assign this a probability that is close to 0. What is the probability of a tossed coin landing on heads? There is a 50-50 or 1 in 2 chance this will occur. So therefore we assign this a probability of 0.5. Remember, the probability of an event occurring must be between 0 and 1 inclusive. In probability, we are usually looking at questions where there is an experiment and outcomes from an experiment. One definition we need to know is the definition for a sample space. The sample space is the set of all possible outcomes of an experiment. For example, if we toss a coin, the set of possible outcomes would be heads or tails. If we roll a die, the set of possible outcomes would be 1, 2, 3, 4, 5, and 6. We could be asked, what is the probability of rolling a 4? To do this, we use the probability formula that the probability of an event is equal to the number of successful outcomes over the total number of outcomes possible. So the probability of rolling a 4 is equal to, there's only one successful outcome, in this case rolling a 4. And if we are rolling a die, there are 6 outcomes. So the probability of rolling a 4 is 1 in 6. Now, what is the probability of rolling an even number? The probability of rolling an even number is equal to the number of successful outcomes. So in this case, we could roll a 2, a 4, or a 6. So the number of successful outcomes is 3, and the total number of outcomes is 6. So our answer is 1/2 when we simplify. Another probability rule I want to look at is the probability that an event doesn't occur is equal to 1 minus the probability that an event has occurred. Let's take a look at this. If we go back to the example of rolling a 4, the probability of not rolling a 4, not 4, is equal to 1 minus the probability of a 4. So we already know that rolling a 4 is a 6th, so 1 minus a 6th will give us 5/6. Using our probability rule, the probability of not rolling a 4 is equal to 5/6. I get this by saying that there are 5 possible outcomes that we'll accept, rolling a 1, 2, 3, 5, or 6, and the number of total outcomes is 6. So the probability of not 4 is 5/6, and the probability of 1 minus rolling a 4 is 5/6. This formula is often used on the Leaving Certificate paper to solve probability questions. A sample space and probability question might consist of 2 fair die are thrown and their values are summed together. This can be seen on our table, where on the top line we can see the values for die 1, 1 through 6, and on the left column we can see the values for die 2. The values in the middle represent the values on the die total together. For example, if I throw a 4 on the first die and a 5 on the second die, overall I'll get a score of 9. This table represents the sample space of the experiment. Let's try some probability questions using this table. What is the probability that the total die value is 8? Looking at our table, we can see 8 appears 5 times. And using our probability formula, the number of successful outcomes is 5 from the table, and the total number of outcomes overall is 36. The second probability question asks us to find the probability that the total die value will be less than 4. Be careful of these questions in case they say equal to or less than. In this case it's less than, so the total value of die 1 and die 2 is less than 4 in 3 locations on the table. Going back to a probability formula, this means the number of successful outcomes is 3, and the total number of outcomes from the table is 36. The probability the die value is less than 4 will be 1/12 when we simplify. For the last question, it asks us to get the probability that the total die value is odd. If we go to the table, we can mark in when the total die value is odd. We will now mark in on the sample space where the total die value is odd. And we find that it is odd in 18 places. So the number of successful outcomes is 18, the total number of outcomes is 36, and this simplifies to a half. That concludes our discussion on probability.